Find L5 and U5 for the definite integral, the integral from 2 to 17 of x minus 5, x minus 13 dx. Okay. Well, L5 and U5 are the lower sum and the upper sum with 5 equal intervals. So I'm going to have to cut this interval from 2 to 17 into 5 equal subintervals, find the maximum minimum on every one, and then multiply by the width of the subinterval and add them up. Okay, so first I'll give it a sketch because then I'll know what it looks like. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now this thing is a quadratic. If I expand it out, I have a plus x squared, so it's going to be going upwards like this. It crosses at 5 and 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so it goes something like this, like that. Y-axis isn't drawn to the same scale, I'm sure, but this will do. And that turning point should happen exactly halfway between, so I'll figure that out. The vertex at x equals, now the average of those, 5 plus 13 over 2, which would be 18 over 2, which is 9. Okay, 6, 7, 8, 9. Okay. All right. So that's cool. And this is the definite integral that we want. It's going to be this bit and then this bit and then this bit. I'm making a guess it's kind of just be negative, I reckon, but I don't know. Yeah. So now I'm going to have to divide the interval from 2 to 17 into 5 equal subintervals. The total width is this width here from 2 to 17, so it'd be end minus beginning, which would be 15 wide. And so the width of each interval, which is normally called delta x, would be the total width divided by the number of pieces, which is 5, and so that is 3. Okay, so that means that if I count over 3s, that'll be the edges of my intervals. So interval endpoints are 2 and then 5, and then another 3 would be 8, and then another 3 would be 11, and then another 3 would be 14, and then another 3 would be 17, and that's the end. Okay, I'm just going to actually draw them in properly. Okay. So now in each of those subintervals, those 5 subintervals, I'm going to need to find the maximum and the minimum value. So let me have a look at this. This first subinterval is decreasing, and so the maximum's here at 2. So subinterval number 1, the max will be the function value at 2. My function doesn't have a name. Why don't we just chuck that in at the front and say let f of x be equal to x minus 5 times x minus 13. And then we can say the maximum will be at f of 2, which will be 2 minus 5 times 2 minus 13, minus 3 times minus 11, which is 33. Yes, I didn't draw it to scale, that's 33 there. And the minimum would be 0 here at 5. So the minimum is f of 5, which is 0. Okay, that's subinterval number 1. Subinterval number 2, the maximum, well, actually it starts being 0 and goes down negative. So the maximum is going to be f of 5, which is 0. And then the minimum is going to be down here at f of 8. So 8 minus 5, 8 minus 13, 3 times minus 5, which is negative 15. Okay. So this next interval, well, the minimum for the entire function is there at 9, so that's definitely the minimum. The maximum, I'm not going to know which one of these it is. It's going to have to be at one of those places, but I don't know which one. Actually, I know which one. it only can go up a little bit to get to 8, so it must go up quite a lot to get to 11. So it's going to have to be there at 11. So let me subinterval number 3. The maximum is going to be at F11. But let's just check and we'll just make sure that we were right. 11 minus 5 times 11 minus 13, which would be, what's 11 minus 5? That'd be 6. And 11 minus 13 is -2, which is -12. Yes, -12 is higher than -15 at this end. Okay, so that is the maximum. And then it's going to feel bad to have that on the other page. I'm going to put it here. The minimum is going to be at f of 9, which is 9 minus 5 times 9 minus 13, which is 4 times -4, which is -16. Okay. On subinterval number 4, the minimum is going to be down here. But I've done the maximum first for each of them. So I'll do the minimum is going to be f of 11, which we've already figured out is -12. And the maximum is going to be at this other end, which is f of 14, which is 14 minus 5 times 14 minus 13, which is 9 times 1, which is 9. Interesting, the minimum's negative and the maximum's positive, but that's okay. Not a problem. That's perfectly all right with these things. Okay. And then finally on subinterval number 5, it's increasing on that subinterval. So the minimum must be here and the maximum must be there. So the minimum is at f of 14, which is 9. And the maximum is at f of 17, which is 17 minus 5, 17 minus 13. Didn't give myself enough room, did I? 12 times 4, which is 48. Okay. So I'm just going to make a table of that. I think I've got everything I need. So I, which is the interval I'm up to, 1, 2, 3, 4, 5. Little mi, which is the minimum, and capital Mi, which is the maximum. So the little m1 is 0. Little m2 is -15. Little m3 is -16. Little m4 is -12. And little m5 is 9. The maximum, 33, 0, -12, 9, and 48. And then to figure out the upper sum, I'm going to have to multiply these all by the delta x. Sorry, the maximums by the delta x, and then add them up. And the minimum would produce the lower sum. So L5 is the sum from I equals 1 to 5 of little mi delta x, which is 0 times 3 minus 15 times 3 minus 16 times 3 minus 12 times 3 plus 9 times 3. And we don't need the 0 times 3, that'll be fine. Minus 15 times 3, minus 16 times 3, minus 12 times 3, plus 9 times 3 is minus 102. Okay, and U5 will be the sum from I equals 1 to 5 of capital Mi delta x, which will be 33 times 3 plus 0 times 3 minus 12 times 3 plus 9 times 3 plus 48 times 3, which would be 33 times 3. I don't need the 0 times 3. Minus 12 times 3. It's 9 times 3 plus 48 times 3 is 234. Okay, so I've narrowed it down to somewhere between minus 102 and 234. I'm going to need a lot more intervals if I'm going to figure out this definite integral to any degree of accuracy. I've currently got it to within about 300 of the right answer, but that's what the answer is.